Thanks, homie. You've been very patient. We just lost like almost 20 minutes of time. Now, for the next like 1 hour and 10 minutes, I'm going to barrel like a big, huge study goal, number 16, about mining and refining. We'll do a couple of little tiny study goals to finish off 9.1, and I'm going to try to get the meat and potatoes of 9.3. So that tomorrow we do a bunch of little follow-up study goals. We'll do the stars, and your test will be on Monday. I think I had this up on the whiteboard last Monday, or up on the screen last Monday. Raise your hand if you think you saw this already. I think it was for study goal 15. So both my period 1 and 2 students saw this one already. Next, study goal number 16. My instructions said we're going to insert a big chunk of notes on different types of mining, so leave about 1 page open. You don't need to copy all of this. I'd rather you write it as I show you pictures of relevant stuff. But you do need the name now. There's a type of mining called placer mining. Remember, I've heard it pronounced placer and placer. I'm still not convinced which one is correct. Placer mining is when you dig up placer deposits like this. Stuff that's been sorted by weight at different stages of a river. So where the river falls up, slows down, all the 1 pound stuff would fall. That's called a placer deposit, stuff that's sorted by weight. And I think in both period 1 and 2, I've already used this example, so I'll go fast. Please look up. A pound of feathers, a pound of brick, a pound of gold. They all weigh a pound, weight is the same, but they have different densities. Touch your nose if this is something you've heard me talk about already. So, since they all have the same weight, if you find all the little 1 pound stuff, you've separated the gold. These homies on the screen have a trough with little wooden bars on the bottom, like chopsticks. And they dump in gravel, and the gravel is big, like a pound of feathers. So the gravel will roll over those bars, but the gold is small. So those little pebbles are trapped on the bars, and so you sort sizes to find the densest material. When it all weighs the same, you sort by size to find the densest material. If you were blindfolded, and I gave you a bunch of things and said, these are 1 pound each. You could grab a pound of feathers and say, yes, that's a pound, probably feathers because it's huge. And then if I gave you something that also weighs a pound that you have to hold with 2 hands, you'd be like, yes, that's a brick. And if I gave you something else that also weighs a pound, but it was very, very small, you could close a fist around it and you would know you were holding gold, even blindfolded, because of the density of these materials. So the smaller stuff of the equal weight is the denser stuff, in this case gold. Placer mining is for gold. Look at this photo, the homies are on a river. Look at this photo, the homies are on a river. Look at this photo. Today, a modern version of small-scale placer mining, that's on a river. This is large-scale placer mining. You can see those dams in the back where they've diverted the river. Look at this, that's a river. You should note, placer deposits are on rivers, so impact is for riparian habitat. And an impact on water quality is sediment pollution. These are the specifics the College Board likes to know about things. Riparian habitat, sediment pollution. Christian, I like your sweatshirt. I like the pattern is good. One of those bullets at the beginning of the slideshow when I told you not to write said placer mining happens a lot in the tundra. Do you all notice that there is not a river? The tundra is cold. But the last time our planet was really, really hot, there used to be rivers up there. Now that it's cold, all that water is locked up as ice caps. So you should note that a lot of placer mining happens in ancient riverbeds where there is no longer water. So a lot of people argue that if you do placer mining on ancient riverbed, now that there's no water, you don't have the same water impacts. People say that tundra placer mining is the cleanest because there used to be a river, but now there's no river, so there's no water, so you don't have that riparian and the pollution problem. Check this out. That's a placer mine on an ancient placer deposit. They had to bring in that water to do the mining. So they excavate what used to be river bottom, and then they have to like bring in trucks of water so that they can jumble around all of the sediment and look for the denser gold. This is all large scale, it's all done mechanically. At the opposite end of the spectrum, there's a type of placer mining that I really need you to know about. I'm going to give you a bunch of bullets on this. It's called tropical placer mining, almost all of which is illegal. This is almost all illegal mining. You all know there's a lot of rain in the rainforest, so there's a lot of rivers in the tropics. Is that okay? A lot of rain, a lot of river. A lot of river means a lot of placer deposits. And there's a lot of things that we can say about this type of mining. It's probably worth noting that this is about half of the world's gold supply. So different years, the number goes just below, just above half. But roughly 50% of the world's gold was mined illegally. In the tropics, these are not permitted mines. The government did not allow these impacts. There's a horrifying overlap with illegal tropical mining and the slave trade. This is laborious manual mining, hand labor. Instead of using machinery, you use screens and like elbow grease, a lot of physical labor. And if you're already mining illegally and you're in the middle of nowhere where nobody can hear you scream, why do the work yourself? And so people who monitor the modern slave trade are extremely picky about where they get their gold because a whole bunch of illegal gold mines are powered by slave labor. You should probably know that. That's like a big global correlate. Same thing about riparian impact because you're on a river. Same thing about sediment pollution because you're on a river. But here's a crazy thought. I was in Brazil and I spent about a week and a half in the heart of the rainforest, and I met a bunch of environmental activists in Manaus, Brazil. They were actually like an hour up the Rio Negro from Manaus, Brazil. And these guys were talking to me about this stuff, and then I came back and I researched it, and it's kind of a global average, so I thought I'd throw this into your class. illegal gold mining is what we call the entry point for tropical deforestation. If you think about it, the tropical forest is a really hostile environment. There's like jaguars and pit vipers and big scary snakes and flies that lay their eggs under your skin, and it's like really scary, and there's a lot of ways to die out there. So most of the stuff that you hear about deforestation in the tropics comes after somebody got there first for the mining. So there's this like dominoes, what do you call it? When the snowball effect, the domino effect? There's a domino effect about deforestation in the tropics. Ranching comes after farming, comes after logging, comes after poaching wildlife, all of which starts with mining. You see, like catching some exotic parrots, that's not really worth like trekking 10 miles into the scary jungle for parrots. And it's not really worth it to go get a couple of tropical hardwoods and then have to carry them on your back out through the dense forest. And the slash and burn agriculture is not really worth it because it's just like corn and soy, and feeding some cattle is not really worth it because meat is so cheap. Think of McDonald's. The one thing that's worth it, that's worth all that risk and all that work, is gold. Gold's really valuable. So in the tropics, what you get is a report that somebody over by Mendez saw some nuggets of gold. So you'll get some prospectors that will like trek through the jungle and go check, and they look around and they go, oh yeah, there's gold around here. So they call in the troops. And they say, yeah, we're gonna need like 400 workers and a couple chainsaws and some rifles and stuff. And you get this caravan that cuts a trail to the spot. They mine, build a little camp, clear some wood for fire and stuff. They hunt some things to eat. They spend a couple of years taking out as much gold as possible. And when they retreat, now you have an access point to a safe space where you can build like a poaching camp to get exotic pets. And now that you've made like a braided network of trails through the jungle, then the exotic lumber industry gets in there and pulls out a couple of nice logs for fancy desks and chairs or whatever. And now that you've thinned out the forest of the valuables, now it makes sense to slash and burn it so you can plant soy or corn in those ashes. And when the soil fertility is gone and you can't really grow valuable crops, then you just let the weeds come up and you bring in the cattle. And when you're done with that, you've got a nice place to put your city. You should definitely note that illegal tropical mines are the point of penetration. They're the starting point for tropical deforestation. When I was in the Amazon forest, everybody was talking about this. Like there's these taxi drivers that use little mopeds to get you around Santa Maria Island. And like everybody there, including the little moped driver, 16-year-old guy, was like telling me about it. Finally, you'll see at the end of our class that illegal tropical mines are associated with mercury poisoning of water. We'll come back to that later so I can explain more at another time. But placer mining has these two extremes. Really clean in ancient riverbeds, really, really dirty for its majority in tropical rainforests where it's done illegally. This is like stolen gold. That's a lot to write. Anybody have questions for me? You gonna say something?
Well, it's all hand done. So
mostly, I mean, generators for compressors for fire hoses. You know, one of our the bees are swarming again. Do you know our custodian Zuka? Anybody know what I'm talking about? He's like a short Brazilian dude, one of our custodians. He was like, what do you call it? Like wildlife preservation ranger in the Amazon. And he worked at a mining camp and he saw the miners and stuff. And almost everything is done by hand, like the screening and the sifting and stuff. But they use like a fire hose off a big compressor, off a generator, to blast the stream banks to put everything into suspension. Then the water will carry it a couple feet down to homies with screens that are sorting. I'm sorry to distract you all. I gotta see what these bees are doing. Just a sec. That's the one from yesterday. I went back inside. My text. Anybody else want to talk about placer mining? Anybody else want to talk about placer mining? Next. Underground mining is the type of mining that you always think about, with like the tunnel and the headlamps and the hard hats. You don't have to write this. You don't have to write this. I'll show you some stuff in a minute. You don't have to write this. Make sure you have the name now, underground mining. You know, like the helmets and the carts and the shovels. So there's the homies with the helmets, and there's the shovels, and there's the carts. This type of mining is almost completely gone today. Human labor isn't worth it. If I make 5 of you work all day, you're not going to bring me enough to pay your salary. It's not worth it. Humans have been replaced with machines everywhere, especially in mining. So check it out. There's a shovel. Here's a donkey cart. We don't really do the type that most people visualize when you hear about underground mining. Those little tiny tunnels that start like burrowing through a deposit to like chip away at coal. That's not really how it works. Nowadays, tunnels are much larger. A tunnel this diameter, like our classroom, a tunnel this diameter would be a pretty small tunnel these days. Like this is small scale underground mining today. Underground mining really doesn't make a lot of sense. It does have a pretty small footprint because you've made a little hole in the ground. So of all the types of mining, this is the smallest impact per unit of material, and you should know that. Because you're not moving that much dirt. Just a little hole in the ground, you're not moving that much dirt. I feel like I should move my swamp trap. Look at the engineering required to go underground now. Like, can you imagine how complicated it is to do all that tunneling? So pretty much today, we only do underground mining when you really, really have to. Like if you're in the middle of a city or you're trying to get a bunch of gold out from underneath Yosemite or whatever that you can't do a normal open pit mine. We only do underground mining when you really have to. Because imagine engineering all those pumps and all of those like driving and getting the electricity down there to light and all the air ventilation. This is too complicated. So now, most of our hard rock mining is open pit mining. I'm going to run. You could write these over. You're back. Okay. Please follow me. See these? No, in here. Follow me. Oh, no. Okay. Look at the size of that hole. That's an open pit mine. the majority of our planet's hard rock mining is open pit mines, like this one. And it's just a big hole, like that's pretty much all the notes you're gonna need. But look at how much sediment pollution we're talking about. Look at how many particulate pollution in the air you're gonna make. The scale of this is really difficult for our brains to piece together. Like if I start throwing numbers, it's really tough to make any sense of them. But please look up for a moment, I'll show you a couple things. The hole across the top is 2.7 miles. That's roughly from here to the top of the mesa. 2.7 miles. That's a big distance. Like if you were to go outside and try to even see the top of the mesa, that is, you know, really far. Then the hole itself is about 0.6 of a mile deep at the moment, this particular hole. It's right near Salt Lake City, Utah. They give tours if you're ever in Utah. That's a lot of dirt that used to be in a space from here to the mesa more than 0.5 mile deep. That's a lot of dirt. And every day the hole gets deeper. So please look up. All of this is all spoils, and it continues this way, and it continues this way. That's all the dirt that came out of the hole. Yeah, Peter, I saw it. Can you see where they're settling? I'm hoping they'll go... Pedro!
Yeah.
I'm hoping that they'll go into that wooden swarm trap. Are they going?
The blue one?
The little white one here.
Yeah, I see it. They're not.
Are they clumping in that bush?
Yeah.
We gotta try to get those at seminar.
Yeah.
Yeah. I want to remind all of you that if I'm digging a hole over here, and I dig my hole all day, every day, for 23 years and counting or whatever, that means my pile of dirt coming out of the hole, the spoils, that's also growing every day. Just a quick little quiz from the water unit. So it's been a while. Does anyone remember which type of pollution is the most prominent in water by volume? The number one water pollutant is? That's the number one source of it. Anyone remember? The most common trash in the ocean? Sediment. And the secret ingredient that makes air pollution more toxic because it forces pollutants to stick into your lungs. Anybody remember what that was? PM, particulate matter. This is why those are such a big deal. Imagine how much sediment pollution. Every day that pile's getting bigger. And all of those particulates in the air, every day the pile's getting bigger. When I say 2.7 miles, your brain starts to estimate. After a couple of feet, your brain can't really visualize distances. So 2.7 miles in your brain doesn't feel very different than 1 mile. It doesn't feel very different than 300 yards, actually. Because our brains just really can't estimate those numbers. You see that little switchback road in the back? Watch these slides, watch. You see that switchback road in the back? Right, that like zigzagging line? This one. Right there. That's a road. So that's how the mining trucks get down to the bottom. Okay? Here's that road, and you can see a mining truck on there. And you all realize that's a 2-lane road, so the trucks can pass each other going up, going down? Everybody good with that concept? 2-lane road for the mining trucks? When I say a 2-lane road, most of you are like, okay, I can scale this hole considering a 2-mile road. A 2-lane road. But when your brain thinks of a 2-lane road, your frame of reference is a consumer vehicle. There's a Tacoma, like mine, behind a mining truck, which is not a consumer vehicle. These are very big trucks. The bed size is more voluminous than this classroom easily. Imagine the machine that loads those trucks. These are really big machines moving a lot of dirt all the time. This doesn't have a steering wheel, it has a command room with 6 operators on the 3rd story. So when you see that truck, consider that a 2-lane road for them is about the size of a 6-lane freeway. Like the 101 near Ventura, kinda? So now, scale that as like the 101 right after Rincon. And then imagine a really big version of that at the bottom of this hole. These are really big. The only limitation is that you have to dig out the entire funnel to go a little deeper. You all understand that about digging a hole? That to go deeper, you have to make the hole bigger? Right? You have to like shave the edges. So at some point, that volume isn't worth moving just for that target.
No, see, Jose's class, they're juniors, so
These are big funnels, so the amount of groundwater pollution is a problem. Look, every time it rains, what's going to happen at the bottom? So open pit mines are a really big problem for groundwater pollution in particular. And they are a primary source globally of particulates and sediment. Available for questions? Please look up. When you have a singular target, like a glob of copper or something, you make a hole in the ground to target that. But when you have a horizontal deposit, like coal, which is sediment, so it occurs in layers, you do something called strip mining. And you have to know that strip mining is the majority of America's coal. I think it's the majority of the world's coal, too. The majority of the world's coal comes from strip mining. And I have very little to tell you. I just wanted to make sure that you see this visual. We say that strip mining is like moving an open pit mine sideways. If you watch the visual, it makes sense. Please look up. Now that I've made an open pit, I can get all that coal out of the ground. And now, if I shave away all of this material, I could get all of that. So I pile it up over here. And you can see that I've moved the pit sideways to get more of that horizontal deposit. Make sense to everybody? So I could carve out this chunk, move it over here, and that would let me access another bit of the deposit. It's an open pit, but it's moving sideways, kind of backfilling as you go to get a layer of stuff. A key ingredient here that you should probably put in your notes is that coal is always mixed with petroleum and natural gas. So open pit mining still has like the sediment and particulate problem, but in particular, hydrocarbons are especially nasty. It's like an oil spill on top of your dirty water. Hydrocarbon pollution. Do you remember that fossil fuels are always mixed together? Does this sound familiar? Hydrocarbons are always mixed together. So all the fossil fuels, when you've got solid coal, there's going to be some liquid petroleum and some natural gas blended in there. So when the water touches all that coal, you just get extra foul runoff. Hydrocarbon pollution in the water. So there's a strip mine moving sideways. The bees have settled. There is a clump ready to be gathered over there. Danica, do you have extreme fears about bees?
I don't want to get some because then I have to get antibiotics.
What?
I told you.
Oh, you did tell me. Yes, you should have extreme fears about it. So you have actual necropsy.
Every time I've gotten stung, if I leave it alone, it like the venom doesn't like spread through my body and go away. It stays in that area.
Knuckin' futz.
And then like starts to get infected.
All these years, I've never heard of such a thing.
It's happened every time I've gotten stung.
Okay, next. There are a few places in the world where coal deposits are massive. They're like an entire tectonic feature in the landscape. You might know that the Appalachian Mountains have a whole lot of coal. How many of you have heard of this? West Virginia coal economies, that crap? Now, the reason they have such coal economies is they have these huge globs of coal. But check this out. As the tectonic plate is eroded, you actually get mountain ranges with a common feature of coal through all of them. It's usually not perfectly horizontal like that, right? Because when you make mountain ranges, you tend to deform stuff. Is that reasonable for everyone? That it's not going to look flat like that? And historically, the coal mining Appalachian economy would, you know, like dig a little hole into that. Or they'd like build like a little thing and then they would like dig down and then try to run like a couple of tunnels through there. And this was like the traditional old school Appalachian coal economy. Back in the 1960s, as machines were getting bigger and engineers were trying interesting stuff, fuel prices were coming down. Some nerds invented a technology that didn't really go anywhere. They said, here's a crazy thought. They said, what if we could strip off all the vegetation, plug the mountain, it was this class that taught me what a plug is, thank you. You could plug the mountain with dynamite. And then blow up the whole mountaintop. Now that the mountain is powdered, you could come by and just push that whole thing over into the neighboring canyon. The idea was, Machines are cheap, humans are expensive, energy is cheap, land is cheap, coal prices are going up. Let's do this thing. And just blow the tops off all the mountains. And the crazy vision back in that day was we could just build a giant parking lot with piles of coal on it. I don't know if you've ever seen a big earth moving job, but moving big piles of dirt is really fast if you have big machines. My father-in-law is a developer. They build like housing complexes with like mini McMansions and stuff. And I've gone down like on a Monday and they're like, yeah, we're gonna just level all that. And I come back on a Friday and it's like a building site. It's amazing the amount of dirt you can move in a couple days. So the idea goes, we'll just remove the mountains, make a parking lot of coal. And there was just one problem. All these hippie environmentalists, they said, no, 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 you're not allowed to do that because does anybody know what's at the bottom of every canyon? Hunter, your phone. What's at the bottom? You don't have to look it up on your phone, buddy. Everybody already knows this. What's at the bottom of every canyon? River and water, that's right. And we have this thing called the Clean Water Act, which says the federal government has to protect all navigable waters that are mapped in the United States. So mountaintop removal, this is another type of technology that you have to know about. Mountaintop removal, MTR. So mountaintop removal was like an interesting idea that just sort of went on the shelf. People were like, yeah, well, you know, that'll just never happen. Because these friggin' environmentalists ruin everything. You were all born in 02? Is that right? 01 maybe? So right when your mamas were pregnant, everything changed. We had a president who was really friendly to the energy sector. His vice president was the former CEO of the world's biggest energy development company. So the energy sector was running the White House for a little while there. And they reinterpreted the Clean Water Act, and the president comes out and says, well, we're going to help America have cheaper energy because it is my interpretation that the Clean Water Act doesn't apply to mountaintop removal because if the river is gone, you don't have anything to put on the map, so we got nothing to protect. I hope you all caught that. He said, if the river is gone and it's not on a map anymore because there's no more river, then there's nothing. And every environmentalist, water quality organization, environmental lawyer in America was like, what did you just say? And every mining company in America was like, what did you just say? And they started just buying up permits like crazy. I always exaggerate. I don't remember the exact number anymore. But in a period of about a year and a half, the United States signed off on something like, I don't know, 600 mountaintop removal permits. And it took a while, you know, for the courts to catch up and block this temporary opening. You should know, mountaintop removal is definitely the biggest and dirtiest type of mining. So we say the worst, but you know that's a claim, right? That's just my opinion. That's like saying that redheads are the worst. It's just a claim. But the amount of impacts makes this really next level. It's not even putting pollution in the river. it's putting so much pollution that you can't find the river anymore. It's not like sediment in your river. It's sediment in your river and then on top of the river and then obscuring the river and then hiding the river forever. It's like so much trash in your house that you can't see the house anymore. Please look up. That's a small mountaintop removal site. And you can see the parking lot with the pile of coal in the middle, right? You'll see that black thing right there in the middle, that big pile of black rocks? That's coal. That's a slightly bigger one. And look at how nice and flat that is. You can just drive right up and the machine goes beep, 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 and they just push over a load of coal for you. Cheap and easy. This was America's cheapest coal ever. Yeah.
How do they detect where the coal is?
I think they use like specially trained gophers. Leprechaun imaging. We call them little people now. I don't know. I think that when you've mapped out your layers, there's these things called benchmark strata. So like, if you know how sandwiches are built and you have like 2 pieces of white bread visible, you can assume that between those 2 there's going to be some peanut butter and some jelly. Because you know how sandwiches are built, you just have to sense the bread to know where the peanut butter and jelly are. So there's like benchmark strata. So we know that this was once a sea bottom. So you find like sandstone that's young, and then you find sandstone that's old, and between those 2 sediment layers, you know that there's going to be some amount of deposit because you've mapped it elsewhere. I think that's it. Yeah?
So if this started happening, coal prices dropped for a while?
They did. They dropped tremendously. And so this was like a spike in coal before Obama. I don't know if you remember, but I showed you like a coal pricing, coal economy graph like a long time ago, the energy thing, and it was just on the screen for a split second. But there was this moment when like the coal economy was huge. That's when you could do this as the cheapest way to get coal. I mean, look at how much dirt that is. Like, I wonder if that's going to be dirty when it rains. Like, can you imagine, like, on a windy day, what it's like being downwind of that? Like, this is so next level. It is the largest manipulation of our landscape for a mineral resource. This is the biggest footprint mining. So that's what I mean by the worst, it's just the biggest mining. Yeah?
Does that also cause those huge landslides?
Well, it can. And check out this scary idea. Oh my God, that's the dirtiest one. That's a really famous one. So check out this idea. Yes. First of all, yes, it does cause. Generally, you engineer it so that it can take runoff. But because you're building it every single day, it's easy to get sloppy. And if the storm comes a day early or whatever, then yeah, you can get like really nasty landslides. The other thing that happens is it's going to rain no matter what you do. So you have to catch all the runoff in these things called impoundment dams, and those break sometimes. So children, watch this. The mine is up there. Like if you look right there, you can kind of see the mine. Like the very, very edge of the mine, it's like right. And then the water comes out of the mine, and so you catch it in an impoundment dam. But then if you go downhill of the dam, you've got like a mining camp, and then like, I don't know what that is, and then a city. So like if this thing breaks, that's just like a tidal wave of nasty ass water coming down the mountain. That's really nar-nar. Any questions about mountaintop removal? Because I think I'm done talking about mining. And we have a second quick little tidbit on number 16. Children, what is ore? It's your warm-up. What is ore? The reason it goes in there is so you're not. What is ore?
Like the rock that something's in.
Yeah, that's pretty close. Anybody else want to try that?
What you take out of the mine before it's refined?
Yeah, that's really good. Ore is what you take out of the mine before it's refined, or the rock that has your resource attached. Don't move this yet. Don't move this yet. Hold on to that for now. Keep that for a second. Don't move this yet. Hold on to that for a second. When you guys pass it along, I'll let Captain take it back to put in. The kids in the front are holding the ore of copper. This is quartz rock with copper oxide on it. Copper oxide. Everybody in the audience, the copper is the blue-green stuff. Kids in the front, if you check it out, you can see that that has blue-green stuff on it. For some of you, it's really blue. For some of you, it's really green. There's one piece that you can see both colors. Who has the one with both colors? Yeah. You have one too? Yeah, nice. If we combined all of these rocks, we could make about 1/8 of a penny worth of copper. So these are very low value ore. But please pass these back to the other students behind you now. I'd like the whole class to see these. How the hell are you going to get that blue stuff out? Like, if you used like a little knife or like a needle or something and just tried to like chip away or carve out that copper, look at how laborious this would be. If I was trying to carve out copper from this rock, I want to spend a lot of hours to get a penny's worth of copper out. Doesn't make any sense. It's not worth it to carve it. There has to be an easier way. Please look up. These are the 3 main refining methods. 3 ways to get the resource out of your rock. If all of you could pass them over to Mendez. These are the 3 different ways. How many of you have heard of the Bronze Age, like a historical period? So for a while, humans used to make their tools out of stone. And then, miracle of miracles, somebody figured out how to make tools out of metal. And that's kind of a lot of technology if you think about it. And the theory goes that somebody had some rock with metal in it around a fire. The fire got really hot, and the metal became runny in the hot rocks. Some of you might know that metals melt, some of them at a temperature much lower than rocks would melt. Lead melts at like 480 degrees or something. Copper at, I don't know, 700-800, I'm just guessing here, aluminum, something like that. So there was probably some homies back in the day relaxing around a really big bonfire, keeping away the saber-toothed tiger or whatever, I don't know. Keeping away the Sasquatch. And around this fire, they had rocks and they were watching, and the rocks started to weep metal. And they were like, holy crap, if you heat up the rocks, the metal pours out. And then it's just a little process of refining to catch that metal in something shaped like an axe, so you can peel that away, and then you get a metal axe. And hooray, you're in the Bronze Age. That process of heating up rocks to melt the metal is called smelting. Heating up the rocks to melt the metal. Melting. Smelting is melting the metal from the rocks. Smelting is melting. the metal from the rock. Globally, we do this by burning coal for the most part, and I hope that you all will always connect coal with SOx. Sulfur oxides, coal, energy source, primary source. So because you're heating this with coal, this is a giant source of sulfur oxide air pollution. Smelters are really bad for air quality. Many parts of the world make it really difficult to smelt. The worst acid rain ever recorded was in a circle around an old smelter in Appalachia. Next, another option is the one that lab is for. Mendez, what's the box say?
Copper mining.
That's it?
Yeah.
That box comes with a bottle of sulfuric acid. It's a kit to do a lab with high school students, where you take all those rocks and you pour sulfuric acid over the top, and the metal separates from the rock, because you all know that acid causes erosion of rocks, right? Remember acid rain, like chemical erosion? So you artificially erode the rocks and all the metal pours out. You catch it in a coffee filter and hooray.
They're about a toker cog.
I hear the tow truck, it's gone.
Yeah, she's gonna go try to see.
They won't let her have it.
Yeah, our friend sent us a message being like, hey, you can park here because they're towing your car.
Yeah, it's gone. She lost.
Yeah.
She might as well come back.
I can tell her.
It's okay, it's okay. She's gonna find, she'll have fun right there.
Yeah.
Alright. If you make all of your ore into a big pile and then you use acids to erode the metal out, that's called heat leach extraction. And when we do this as a lab in my classroom, it's really easy. But if you do this at like a gigantic industrial scale, the acid waste and acid spillage are a really big obstacle. Finally, remember I told you that in the tropics there's mercury pollution from the gold mines? So I need you all to know the name, and then I don't think the College Board needs you to explain the technology. Hunter, how's it going back there? Good. Joan? Mercury amalgamation is when you shake up a bunch of gold ore with mercury. You don't have to know the process, but the gold and the mercury stick together. Then you skim off all the rocks and you separate the two with nitric acid. It's actually pretty simple, mechanically speaking. Here's the stuff I would like you to note. Mercury amalgamation is largely illegal. Very, very, very crude and primitive. But it's simple and portable. So remember when I said there was this prospector, Mendez, who found the gold nuggets in the forest that I wanted to go explore, and I'm going to take some chainsaw and some rifles and some involuntary workers? The other thing I'm going to take is a barrel of mercury and a barrel of nitric acid. All you need is like 2 ingredients, and you pour one, shake it, clean off the rocks, pour in the other one, shake it, pour out the mercury solution, and you're left with clean gold. It's illegal, but it's effective. It's simple. It works. You can like just put that on the back of a horse, and then you come out with like $10,000 in gold. It's like really effective. So a shocking statistic that I also learned on my trip to the Amazon is that the most extreme mercury pollution ever found in fish is not tuna or even dolphins. It's actually a small pocket of catfish in the Amazon River. In the part where I was, I ate some of that and then I found out that it's really high in mercury. They're called red-tailed catfish. It was delicious. Anybody ever been to Red Rock at the end of Paradise Road? Hey, there's a beach. You've been there? If you go up canyon, like up the river toward Gibraltar Dam, at about the 2-mile mark, there's a sign that says, "Don't catch fish here, they have mercury contamination." Because back in the day, there was a gold mine by the Gibraltar Reservoir and they used this. And there's still mercury left in the river. Mercury is very heavy, so it sinks to the bottom of the water. We talked about mining, we talked about refining. That was like a long babble list for number 16. Anybody want to ask me anything about all those notes you were supposed to write down? Yes, Chris? What? Make a pile of ore. Use acids to quote unquote artificially erode the ore. And so you free up the metal. Does that make sense? Heat leach, you make a pile and then you leach out. Yeah. Question? Say it.
Do they use the acid that's produced from coal scrubbing?
I think you could because they're both sulfuric acid, yes.
Okay.
Yeah, you can imagine that in a lot of these mining economies, there's all these interconnected products that don't have to travel very far. What else? Yes?
For open pit mining, do they have to restore the land after?
Boom! Number 17. If you could please look up, that's obviously a mine. And that's obviously a mine. And nobody wants to look at that crap. So when you're done, you gotta do something. That's also a mine and that's also a mine. But the ones that are green have been reclaimed. Number 17, you have to know that reclamation is not restoration. Does anybody remember what restoration meant in unit number 2 or 3 or something? Yeah?
If you mess up land somewhere, you would fix lands like an equivalent amount of land somewhere else.
Okay, so that's mitigation when you do it someplace else, but that is restoration when you fix something up to be ecologically functional. Reclamation is making it human functional. Reclamation is to take a mine site and make it good enough for humans to use. Do something with it that's good enough for people. Not ecology, but for people. So look, that's covered up the hole, but still kind of nasty. Is that reclaimed? Like, here we've covered up the hole sort of, but it's like a big mud hole. Is that good enough? Like, what if we just plant some seeds on it? Or what if we make it into a park? Like Ealing's that used to be a landfill. Apparently they found a big adult mountain lion at Ealing's. Y'all heard about this? Yeah. Kind of exciting. Reclamation is the process of taking a big impacted land area and making it somehow usable for people. But I think I'm done with 9.1 unless you wanted to ask me something. Yeah?
For all the different types of mining, were the only legal ones the open pit and strip?
No, and to be clear, all of these have a legal way. Placer mining is done legally in the US. There's a very clean type of placer mining that's common in the tundra, like Canada and Russia. But an interesting detail of gold is that it's really valuable, so a whole bunch of gold comes from illegal mines. So the most commonly practiced illegal type is placer mining, but all of them can be done legally. You could do an illegal open pit mine, but it'd be pretty tough to hide that. And I guess you could do an illegal strip mine, but that'd be pretty tough to hide too. Mountaintop removal is generally impossible to do within current US law, but there was a brief period right before you were born when it became common, and a lot of those permits are still valid. Yes?
Has anyone ever been permitted to do tropical placer mining, where it wasn't illegal? Or is it?
I would assume so. Interesting thing about the tropics is most of the tropics is already protected. So in Brazil, pretty much all the Amazon rainforest, with very few exceptions, is protected. There's just a few little pockets that are developed. Funny thing is that a lot of those places are protected in paperwork sense, but once you get out there, who's going to enforce that? The furthest you can be from a human is in the tropics. Maybe not. That's probably not true. But anyway, in the US, you're no more than 19.9 miles away from asphalt anywhere in the continental US. So it's easy to enforce here. You can't sneak anything that big into the US. But in the tropics, you can get pretty far from people. Anybody else? Last call? Switch to 9.3. Let's do the vocab. You can see why I pushed off the test. 9.3 vocab questions. We just have a few minutes. Let's use them. vocab, Chris? Night soil is poo-poo fertilizer, human manure, aka humanure. And Chris, humanure is probably one of the best fertilizers ever because we have an excellent, abundant diet. Human poop would probably be the best way to build compost if you could choose. But the problem is our diet has too many weird ingredients now, especially all the medications. How many of you remember the story about my dog eating heroin addict poop? So there's an example that a lot of the stuff that ends up in our waste stream makes our poop too gnarly to use as compost. Birth control, antidepressants, opiates, a variety of painkillers, chemo treatments, they all leave in our poop, so our net waste stream is too dirty to use as compost. Back in the day, the Santa Barbara wastewater facility used to take all the poop and make compost with it. And then the company that took it said, no, I'm sorry, your poop is too dirty. Not like bacteria dirty, but like ingredients. Other vocabs in 9.3, yes, Jessica?
Microlayer.
The microlayer is the thin biologically active layer at the top of water or topsoil. So it's where all the biological activity happens. In the ocean or in land. It's like 1/4 of an inch is almost all the photosynthesis on Earth. What else? No other vocab questions? 9.3? How many minutes do I have left? 4? Perfect. Watch this. Just enough time. Please look up. I'm glad you already copied it because I've got like 4 minutes and that'll be just enough for number 19. These are some tightly packed classes. You're such troopers. integrated waste management is using all the possible tools to shrink our waste stream to the bare minimum that has to go in a landfill. Our economy makes a lot of stuff that we don't want to use anymore. But putting stuff in a landfill is stupid. Like, we just spent money and effort and intellectual capacity to make things, and then we're going to bury them and like never do anything with them again and then have to rebuild them all from scratch again? That's stupid. So integrated waste management is using as many things as possible to shrink the waste stream so that less goes to a landfill. Tomorrow we'll talk about landfills. But for now, all these underlined words are things you're supposed to know about. And most of them are really simple, so I don't have a ton to say, but you can stop me. Source reduction is stuff that you do at home to make less trash. Like, hey, I'm done with this tapatio, but maybe I can cut off the top and make a drinking glass out of that so that I make less trash. That's called source reduction. Or, I'm going to buy really nice tools so I don't have to throw out crappy tools every year. Source reduction. Decisions that we can make to produce less trash in the first place. Bringing your own mug to the coffee shop or whatever. Then, there's things that we do within our disposal systems that's called diversion or recovery, and these are ranked from the most common recycling to the least common. So almost everywhere in the world, we recycle at least the metal, maybe the glass, sometimes the plastic, rarely the paper. Recycling is by far the most common diversion globally. Sometimes if you live in a pretty hip town, they might like mulch or like take out the organics for some other purpose or make compost. Like in Santa Barbara, we're starting to do more and more of that. Please note on your paper, hazmat and e-waste still goes to the landfill, but we got to do something else on the way. Like you got to dry out the paint, then put it in a bag before you put it in the ground. This is still going to a landfill, but it just takes extra attention to minimize the impact. And like the holy grail, like the rarest unicorn, is to reclaim water or make energy by incinerating the trash or using the methane for a power plant, biogas. If somebody could please make a note on their drawing that we got to here. Thanks for trying so hard today. That was a really long lecture. Good job. Hold on. I don't want to broadcast your comments.